would you rate like your general awareness with IPv6 on a scale of 1 to 10? So 10 being the highest and 1 being the lowest.
One.
That wasn't slow at all, Kerry. That was straight on one. What about you, Alex? How would you rate your confidence or your general awareness of IPv6?
Probably a 5 or 6.
Yeah, that's good. Yeah. And okay, yeah, so let's go. Okay. So Mark, what about you?
If he's a 6, I'll go with a 3.5.
Nice, nice. Okay, yeah. We said 7.5. Balaram, what about you? What's your? I'm not sure if I'm pronouncing your name right, but yeah. So how would you rate like your awareness or general awareness with IPv6? Would you say you're a 1 or you're a 10? If 10 is the highest. Yeah. So actually, there's no need to ask Powell and Sarah. We'll just rate them 11. So uh, Powell 11, Sarah 11. Yeah. No, I don't.
No, absolutely not. I would say one. No, no. I
No.
was no, no. Let me clarify. I'll say
Okay.
why to you because when I gave my CCNT, the ICND one,
Yeah.
there was no IPv6.
Yeah, that's
So
true.
when I did my reading online about the ICND two,
Yeah.
I found out they will not test you on IP version 6, and you have to believe me when I say I did not touch IP version 6. Now for the route exam, I am going to start after I finish with EIGRP.
Yeah, okay, yeah, okay, yeah, I see, but I still don't believe that. But well, Powell says
So
1.7 to 1.9. That's what Powell said. Who in this Hangout has ever attended this Hangout believe Powell? That Powell is
no, I don't
1.7.
believe. I
I
don't believe him.
absolutely don't believe you, Powell.
If you times it by 10 or 100, then
Absolutely,
sure.
yeah, I absolutely don't believe Powell, and I don't believe Sarah too. So, so I
Well,
know.
I'm going to be very honest. So you have to believe me. We can test free today.
We'll see. Okay, let's get started with this one. So while this, I'll just do a quick screen share, and we'll start basically using the same method that we did last week, which is we'll have like a little task to do, and then we'll give our answers, and then we'll go from there. So
David, I was
carry
thinking
on.
this session is with distance vector and link state because that's what the Hangout says.
Yeah, that was my mistake. Because what happened was we were supposed to start 3 weeks ago, and then there was like a bit of some stuff that were going on, so we could not start. So then we moved
Okay.
it like
Hey
to
guys,
yeah, a week ago. So basically we're
I'm gonna
running
run and
1 week
grab my
late.
headphones
Carry on,
so
Mark.
I can.
What's the question, Mark?
I'm gonna run and grab my headphones. I'll just be right back in like two
No
minutes.
problems.
One
Yeah,
minute.
sure, sure, no problems. Yeah. So that's the reason, Sarah. Sorry about that. So that was my bad. I should have corrected that. Um,
That's fine.
so we're
That's
supposed
fine.
to start IPv4, IPv6, then routine basics, and but then like so if I just search for Cisco router and um, images, let's get a good Cisco router. Um, copy the image. Let's get myself nice diagram here. So we have a router in the branch office and another router in the headquarters. Let's see. Okay, so here we need 15 networks with I'll mute some microphones so it won't impact the recording. Um, but you can unmute yourself if you have like any comment or anything to add or something like that. Okay, so we want 15 networks with let's say 200 hosts per network. And on this other side, um, we want 40 networks. Actually, not 40. Let's say we want 100 networks with um, network. So we'll actually still go back and do like the whole basics of IPv6, but let's start with this first. So you've gone to your ISP. So this router is connected to your ISP, and your ISP has basically given you a range of a slash 64,
Okay.
and your ISP has given you here in your other location. Actually, let's change this. Let's say this one is slash 48. Let's change this from slash 64. So we'll come back. So just to emphasize something that we try to do in a Hangout is try to make things simple. So we discuss with each other and we help each other out. Let's call this slash let's say slash 50. It's hard that will happen, but let's say that. So we have these two scenarios. So you have two locations. So in one location, your ISP is giving you an IP, basically a block of IP address of A slash 50 and B slash 48. So want you to create subnets for this network. So what would your answers be, or how would you go about something like this? So who wants to go first? So who wants to go first? So this is the scenario that you're trying to solve. So how would you go about something like this? Alex, want to go first?
Sure.
Yeah.
Why not?
So how would you approach something like this? So again, one of the reasons why we're thinking of let's start this one this way is to prove that
Yeah.
IPv6 is really simpler than we usually think before. Because this kind of situation in IPv4 is actually a bit much more complex than IPv6. But yeah, so if you just let us know, like, how would you approach something like this?
I mean, I would, in my mind,
Yep.
the host, no matter what we do, the networks, whatever we do, the further we go to the right, the more networks we get.
Yeah.
So we're gonna always pass the amount of networks that we need.
Mm-hmm.
But I would first look at the amount of hosts that I need, and then start counting the bits.
Look at the amount of hosts needed.
The host per network.
Yeah, hosts per network needed, and then start counting the bits, right?
Yeah.
Okay. So that's Alex's idea of how he's going to approach something like this. So who else wants to go? So Kerry, you want to go for that, or Mark? You want to try that? So what would be your approach? Yeah, carry on.
Mark could go ahead.
Kerry, no!
You can't delegate.
No, it's true, Kerry. You can't delegate. So
With this,
yeah,
I mean, I haven't studied. Basically, I really don't know
yeah,
because when I look at it, it just looks like, oh,
yeah. I know.
Well,
Yeah,
because
how would you approach it for IPv4?
okay,
that's a
for
good question. That's a good question. Yeah.
IPv4, I would look at the host, the amount of hosts that I need,
Mm-hmm.
and then start just as well, I'll do the counting of the bits just as
Yep.
as what was that? Who said that? Mark?
Alex.
Alex said. Because that's how I would normally do for IPv4.
Yep. Okay. Good one. Okay, let's carry on. Mark, what about you? Mark, now you're muted. You can't mute yourself now. You have to unmute yourself. You're muted. You have to unmute yourself. Yeah.
Oh, okay, all right. My bad. Okay, well, basically what I would do, I believe, like, with IPv6, because there's so many hosts,
Yep.
you don't really have to subnet it.
Yep.
I would just put a 1 at the end, 1 through 15,
Nice
and
one.
keep everything.
really,
in the
really,
middle 0.
so actually, I think you would get like maybe 15 stars for that. You should get 15 stars for that answer because that's a really important point in this whole hangout that Mark is bringing up. He says because IPv6, so repeat it again so I can put it exactly the way you've put it because that's so well put. So because
He said
IPv6, yeah,
IPv6 has so many available IP addresses
yeah,
that you don't really have to subnet for hosts. You don't have to worry about like if I have enough hosts. So I would just put all zeros and then the number. Obviously, you need the 15 networks,
yeah.
and I'd probably use like I think EU64 does that, but that's probably further on in
You've been
this,
doing, I
right?
can tell you've been doing some reading, Mark, which is really, really good.
Yeah.
So that's really, really good. So
Yeah.
yeah, because what Mark is saying basically is that in IPv6, you really don't need to be concerned about the host part of the subnetting. You only need to be concerned about the network part of subnetting, which is something that will expand again when we go back. But let's get some other thoughts. So what about you, Moise? Am I pronouncing your name correctly? I've skipped Balaram. Balaram, you've been quiet. So how would you approach something like this? If you give us your thoughts, how would you approach a situation where you have to subnet something like this?
Actually, hello.
Hello.
Actually, I don't have any idea. Hello. Actually, I don't have any idea of an IPv6.
Yeah.
That's why.
Yeah, that's
So,
absolutely okay. Yeah.
so that's why I'm learning from you guys only. That first time only I'm learning IPv6. That's why I'm
Absolutely,
quite.
absolutely okay. But again, let's just say generally, like, how would you like typically approach something like this in IPv4, like normally?
Normally, only I think I know about that. There is so many. This 32-bit consist of IPv4 and IPv6 of 128-bit,
Yeah,
and this much difference I know, but I never go through that IPv6. What is there? How to do that? How to configure and all that things.
yeah, okay, yeah, no problems. Yeah, so it's one of the reasons why we're having the hangout.
Sorry
Oh,
for
okay.
that. Without knowing all the things I came.
Um, hmm. Okay, no problems. Yeah, that's good. Okay, what about you, Moise? Like, oh, okay, like noise, Moise. Okay, yeah, good one. Sorry about that. So, what's your thought about this one? So, you got this to subnet, you got two networks given to you by your ISP. How would you proceed with something like this? So, you need 15 networks in one location. You need 100 networks in your headquarter location. What would you do? So, we're listening, Moise. Ah, is your mic okay? Because we can hear you. Hmm. Okay, yeah, sorry. Yeah, maybe. I'm not sure. Okay, no problems. Yeah. So once you get it working, let us know. Okay. Then yeah, we go for we Powell already gave, of course, as usual, Kevin, what do you expect? But Powell's got the the whole information in the chat window. But let's go for Sarah. Sarah. So Sarah, like, how would you approach something like this?
Okay, assuming that we are going to go for the global unicast addresses,
Yep,
so you have the first 48 bits which are fixed as a prefix, then
yep,
you would have the subnet bits which are 16,
yep.
and then the last, the latter part is completely for your interface IP addresses. That's 64 bits.
Yeah. So Sarah, let's go over that slowly so we can write it down for others. So you said
Okay.
first 48 bits.
Right, a global unicast
Yep,
address is what
yep,
I speak about.
yep,
So the first 48 bits would be your prefix. Like for IP version 4,
yep,
you have classes over here. For IP version 6, you do not have classes,
yep.
right? It's like you have linked local unicast and global unicast addresses.
Mm-hmm,
So the first 48 bits for a global unicast,
mm-hmm,
it represents, let's say, the network ID.
mm-hmm.
Like for IP version 4, you have class A, class B, class C.
Yep,
For IP version 6, for global unicast, it's 48 bits that represent the network ID.
yep. Okay.
Okay.
Yeah.
Then, yeah, we remember that an IP version 6 address has 128 bits,
Yeah.
right? The middle part is the subnet ID.
Good one.
Okay.
Yep.
That is your 16 bits.
Yep. Yep.
And I think Mark is his name, as he
Yeah.
said, yeah, the easiest way for the interface IP addresses is to
Yeah.
start off with 1 towards the last bit. So that is 64 bits for interface ID.
Good one. So after Sarah's explanation, does anyone still believe Sarah that Sarah is only one?
No.
Of course, we know Sarah is not one.
Oh, that's
we,
where my knowledge ends,
we,
believe me.
we know you're a secret CCIE. You're just this is way for the interface to start with the last bit. Okay.
Yeah.
Um, with one and then basically go from there. Okay, so really, really nice answers from everyone. Really, really excellent answers. And let me just read out Powell's answer in the chat window and Moi's answer. It says we have range AAA00. No need to subnet, I agree. And that is not mandatory, but we usually leave 64 bits in the host part, so it gives us more than 200. So number of hosts is not as important as in IPv4. And one more thing, ISP give us at least network slash 56, but most likely net slash 48, you mean? Yeah, okay, slash 48, yeah. Excellent. So let's go back to the very beginning of this one then. So to help like and the rest of us in terms of situations like this. So with IPv6, um, what we do have with IPv6 is this. Um, so we know like IPv4 as we know it as 120 as 32 bits. So we have a IPv4 address. Um, an IPv4 address as 32 bits, which is basically we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 bits separated by dots, coming to a total of 32 bits in an IPv4 address. But in an IPv6 address, which we all know, um, is how many bits? Kerry, like how many bits is IPv6? Yeah, Kerry, can hear you.
128.
Okay.
128.
Yeah, so we have 128 bits. And how is that 128 bit? How is it written?
It's basically 4 8s.
Yep,
Yeah.
yep. So we've got okay, so you have this one separated in eight blocks basically. 1, 2, 3, 4, 5, 6, 7, 8. So each character, what does it represent? How many bits does each character represent? So we're just quickly running through some basics. So how many character does each sorry, how many bits does each character represent? So Alex or Mark or anyone want to assist with that? How many bits does each character of an IPv6 represent?
16.
One character, not one block.
Oh, 4 bits.
Yeah, good. So each character represents a 4 bits. So normally we'll have, you know, if we're using decimal like in IPv4, we have 1 to 10. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But in IPv6, we also have 1, because it uses hexadecimal, 3, 4, 5, 6, 7, 8, 9. Then what do we have after 9? We have
10.
a hey, yeah? and then we have a B, we have a C, we have a D, we have a E, we have a F. This representing 10, 11, 12, 13, 14, 15. And that gives us like the whole characters that we have in the hexadecimal. So basically, if you're saying you have an A here, A is talking about a 10, right? And what that is talking about is normally you have, you have in your binary, or when you're breaking this down, you have something like 1, 2, 4, 8, right? So normally, no, I'll need to get mic later. Yeah. Okay. So normally what we'll have is this one. So our A, which represents a 10, in that case will be 1 here, 0 here, 1 here, 0 here. I'm not sure if that's clear to Balaram and Kerry and Alex and Mark. Is this clear?
I think Mark disconnected.
Ah, okay. Yeah. But is this clear to like Alex and Kerry and Balaram? Is this clear?
Mhm.
Yes.
Yeah. So basically,
Doesn't it start at 0?
as in which one? You mean this one? No, it doesn't start at 0. No. It starts at 2 exponential 0, which is 1.
Okay.
Yeah, so it doesn't start at 0. So, because if you think about it, in our IPv4, we'll have 16, right?
Yeah.
Then we have 32. Then we'll have 64. Then we have 128. And that leads us to have 8 bits. So you have 1 bit, 2 bits, 3 bits, 4 bits, 5 bits, 6 bits, 7 bits, 8 bits.
I think Mark is trying to get back in.
Yeah, okay. I'll need to, let's see.
He's probably sending invite.
Let me try to get the link and send the link to him. Okay, but is this one clear in terms of like the whole breakdown? So we have one bit in terms of this one.
Yeah.
We have four bits per character. So that means this whole block is 16 bits. So that's how we get 128 bits. So we have 16 bits in 8 blocks. So all these ones give us 128 bits in total.
David, I think if you break down 3
Yeah.
and SFS for
Yeah.
them,
Yeah.
it would be easier for them to understand. Because when you have 8, 4, 2, 1, just put
okay.
3.
Good one.
Yeah.
So let's do that. So what Sarah is saying is this. So we got 8, 4, 2, 1.
You could probably write 3 FFF
Yeah.
over there. You can break it down then.
Yeah. Okay. So let's go. Let's take this one down a bit. So what Sarah is saying is this is that if we have like just FFFF.
No, make it 3 FF just for the first octet. 3 FFF.
Oh, okay, yeah. You mean 3 FFF. Something like this. Okay. And then try to break this one down. Okay. So what would this one represent in binary if we want to write this one? Anyone wants to go for that? So want to write 3. So we know that each character of the IPv6 address is 4 bits. So that means this 3, what will it represent?
0, 0, 1, 1.
Okay, so let's write that down. So you say it's 0, then
0,
0,
1,
1, 1. Good one. What about the F?
Well, it would be all ones.
Good one.
Yes.
Excellent.
F is all 15, so all those 4 total up to 15.
Okay.
Yeah, is that clear? Or does anyone have any question regarding that? Is that clear?
I'm kind of wondering again why 0 isn't there, because if none of them are on, then it equals to 0.
Sarah, you want to help to answer that? So what?
I'm sorry.
What
Can
Alex?
you say that again?
Yeah, repeat the question, Alex.
Well, if essentially I'm wondering why 0 isn't there, because if they're all off, then it's equal to 0.
Are we speaking about the first one, 3?
So I think what Alex is saying is that we're starting with a 1, not with a 0.
Oh,
So
why
this
are we
one
not
is, yeah. So why is this one 1, 2? Why is it not 0, 1, 2, 4? Why is it 1, 2, 4, 8?
Because the power, 1 to the power of, 2 to the power of 2 is 4, 4 to the power of 2 is 8.
Yeah. And the
Yeah,
very first
Okay.
one is 2 to the power of 0, which is 1.
okay.
Okay.
I'm not sure if that's clear. Alex, is that clear?
It is correct.
Yeah.
That's the same way you follow it for IP version
For IP
4
version 4.
also.
Yeah.
Yeah.
So it's
Yeah.
basically the same. I know it can be a bit confusing when one is just starting with with this one, because you're like, does it start with a 0 or does it start with a 1? All you need to know is that the last,
Yeah.
if you're using IPv4, you have 8 bits, right? And you know that the last value to your left is always 128. Now, if you count 128 back, by the time you get to 0, you know that it's more than 8 bits, right?
Yeah.
Because now we have 9 bits. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. You know that this can't be correct, right?
Mm.
Yeah. So that shows that the first character is 1, because that's 2 raised to power 0. So you just start counting from 1, and basically you start multiplying by 2.
Okay.
Yeah. Okay. So again, so this one, F will be 1, 1, 1, 1. So I think that is clear. Is that clear? Balaram, is that clear? Or is that confusing?
Yeah, I'm clear
No,
about it.
it's clear. It's
Yeah.
clear.
So basically, we have 128-bit address space, right? Every single character is 4 bits. You know, the whole block is 16 bits, so everything together makes 128 bits. So let's try to break it down in terms of the original question we started with. So what Sarah and Mark, can someone please try to contact Mark and try to bring him back here?
I think
I'm
he's
here.
He's
working.
here.
Oh,
I'm
okay,
back.
yeah. Sorry about that. Yeah. Okay, good one. So just to bring, so what Sarah and Mark said, and Powell said, to make it a bit like much more reasonable, is that normally if you go to your ISP, right, Kevin and Alex, you go to your ISP and you say, hey, I need a block of IP addresses, right? Or normally you're a home user, you go to your ISP and say, hello ISP, I need an IP address. They'll send you the little modem, right? You get the
Mm-hmm.
modem, you plug it in, your modem has a single IP address, right?
Mm-hmm.
But normally in IPv6 or with IPv6, you go to your ISP and you say, "Hi ISP, I need an IP address." What your ISP will typically give you is they'll give you this first 3 blocks. That's what they'll give you. Typically, that's not as if that's the only thing that they can give you, but typically what they will give you is these 3 blocks. So they will say, Alex, you've got A 111, yeah. So you can do with it whatever you want. So they will say, Kerry, you got um, BBBB, 2222. So Kerry, whatever you want, you can do with that, you know.
Okay.
And they say to Balaram, you say, well, you got DDDD, DDDD, DDDD. So whatever you want, you can do with that. So this is like really important, because this first 3 blocks, how many bits is it? Again, remember that one character is 4 bits, right? One block
Mm-hmm.
is 16 bits. So 3 blocks will be how many bits?
48.
Exactly, good one. That's where we get our /48 from. So typically, if you
Oh.
go to an ISP, you get a /48. Typically, again, that's not like what you always get, but we'll talk about that later, about what you get, or what determines what you get. But typically, you get a /48.
Oh, I'm understanding a bit now.
Yeah, good, good. So what Sarah now brought out, which is really, really important, is that now you got /48 here, right?
Mm-hmm.
These last ones, these last 4 blocks, it is always host addresses. The one that you have to subnet is this middle bit, the 16 bit. So let's go back to what Sarah said and let's try to analyze it together. So what Sarah said is the first 48 bits will be your prefix, which is your network ID, right? So that's what she said. It said the first
Mm-hmm.
48 bit will be your prefix, which is your network ID. So again, what your ISP will just give you is your network ID. Like, here's a network ID for you, do with it as you want. She now mentioned something, said the middle part, the 16 bit, is the subnet ID. In other words, the only thing that you typically concern yourself with subnetting is this middle bit. This other bit will always be the host on this network. But this part is the only one that you have to concern yourself with subnetting. And this is enough because from this one, how many networks can you get from these 4 characters? How many networks? So let's try to go over it slowly. So
2 to the power 16, right?
good one. And how did you get the 16?
It's 16 bits.
Yeah. Okay. So let's ask a question to make it easy. So that Kevin and Balaram will catch on to this. So so your IPv6 network, right? Let's say you have 192.168.1.0/24. Now /24 means that this last part belongs to the host, right? Again, I'll mute the mic just for yeah. Okay. So /0 means that this belongs to the host, right?
Yeah.
Yeah. Let me just get the mic to mute the mic. Okay. Yeah. Sorry. Okay. So /0 means that this belongs to the host. /1 means that this is the network that we're dealing with, right? Right? I'm not sure. Anyone want to confirm that? So /1 means this is the network that we're typically dealing with. So this is the network we're on. This part belongs to the host.
Yes.
Yeah.
IP version 4? No. IP version 4, that class 192 is class C address. So your first 3 octets belong to the
to the network.
To the network. Yeah.
Yeah.
So your next network would be it wouldn't be subnetted, but yes, 192.168.1.2.
That's
Yeah, carry on.
That's a classful address.
Yeah.
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 If it was CIDR,
Yeah.
CIDR, then I guess you could do it that way.
Yeah. Yeah. So that's absolutely accurate. What both Taylor and Mark, I assume, right, said.
Yes.
Well, let's put it this way. Let's say you now have something like this where you have 192.168.0.0 and you want to basically you want this bit is what you have to create your networks. And you want, let's say you want 100 networks, right? So you want 100 networks from this bit. So what will determine how many networks you can create from this octet? What will determine that?
255.
Because that means you have 8 bits, right? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 bits, and from this 8 bits will determine how many networks you can create. So normally you go to
255.
yeah, exactly. 2 exponential.
250.
Yeah. Carry on. What were you saying?
Yeah, I was gonna say like 255 would be right.
Yeah. So that would be 2 exponential 8 is 256, right?
256. Yeah.
And you're not subtracting anything because you can use 0 also. You can use 0 up all the way to 255. So that means you have 256 networks that you can create. So now take the same thing. Kerry, take the same thing, and Balaram and Alex, take the same thing, apply it to this. So here, you don't have, again, remember that each character is 4 bits. So what that means is you have 1, 2, 3, 4, 1, 2, 3, 4, second character, 1, 2, 3, 4, third character, 1, 2, 3, 4, fourth character. So 2 exponential 16 determines how many networks you can create from this 16-bit here. And what is 2 exponential 16?
Okay, I have a question.
Carry on, Sarah.
Yeah, the rest of the crowd over here, how comfortable are they with IP version 4 and the binary system?
Yeah, good question.
Yeah, because no, to be very honest, IP
Yeah.
version 6, you need to understand the binary, it's the foundation.
Yeah.
So, are they okay with it? Are they comfortable, or are they just getting started with IP version 4?
What do you think? Like, I know Alex,
I'm
I know
comfortable.
I know Kerry is comfortable. I
Yeah.
know Alex because Alex has been. I think Alex, like, yeah.
I've been
What do you
here
think,
a
guys? Are
while.
you comfortable with IPv4? Yeah, you may need some. I know. I understand that we all need like refresher sometimes and stuff like
Yeah,
that. Yeah, but you're comfortable with IPv4, right?
yeah.
Yeah. Ah, Powell, sorry, I missed all your messages and Moise also. Okay, so are we also we're saying that we understand like what Sarah is talking about is that we get like the side of IP version 4. So basically, if you can understand that, IP version 6 is actually like a more simpler version of IP version 4. And we'll explain why I will explain the reason why you think that, and we can all give our thoughts regarding that. But again, remember, so that means you have 2 exponential 16, and what Balaram has rightly pointed out, that means we can have 65,536 networks.
Yeah, 2 to power 16.
Yes. So that means what that means is this. Again, let's try to make it simple. So you go to your ISP. Hey, someone is calling again. I'm not sure who is calling again. Nan, is that Sarah? Okay.
No,
Ah, no. Yeah. Okay. Let's go back to this one. Okay. So what we're saying is this. So Kevin, Alex, Balaram, when you go to your ISP gives you this IP address here. This belongs to Alex. This is Alex's IP address to do with as you want. So Alex can go a.
I'm not seeing your screen.
Oh, okay. Is everyone having that same issue, or can you see my screen?
Uh, it kind of
I can see
phases
it.
in and out. The
Kevin, what about you?
differences
Can you see it now,
frequently.
Kevin? So I
No.
need to maybe I can stop and reshare it. Let me stop and reshare my screen. So let's stop screen sharing, and then I'll start screen sharing again. So what about now? Can you see my screen
No.
now?
Yes.
Ah, thanks very much for that, Sarah.
Yes.
Yeah, yeah. Okay, so Sarah just posted something like a picture that will help in the chat window. Let's have a quick look at that.
oh, I'm speaking and I was on mute. Okay, this is the IP version 6. Yeah, so it represents like shows each of the hextet,
Yeah.
which is actually called an octet in IP version 4.
Mm-hmm.
So yeah, this is just a representation. If you have a look at this while working with IP version 6, it will make it easier for you.
Yeah, good one. Good one. Good one. Yeah. So yeah. So what we're saying, so you have this one, so you have this from your ISP, Alex, 1111/48, right?
Hmm.
So what you can do is you can say, well, 111 0001. That's a network, right?
Yeah.
And now what slash will it be? It won't be /48 anymore. It'll be slash what?
64.
Good one. /64. And basically, what that means is that all these ones belong to you, the host, right? And this middle one is the one that you're using for subnetting. And from this middle one, you can have over 65,000 subnet. Now, how many companies do you know that for a single, location, they have 65,000 networks?
Uh, very big companies.
Even very big companies, in this, I mean, we're referring to a single location here. We're not referring to
Okay.
worldwide. We're referring to a single location. So you go to your ISP, you have an office in London, you have an office in Germany. You go to ISP in Germany, they give you a /48. You have you have an office in London, they give you a /48. Inside your
Yeah.
London office, you're not going to have 65,000 networks. But
No.
addresses are so much in IPv6 that basically, yeah, actually,
Imagine trying to be the manager for that.
actually, actually, there's an RFC for this. Let's see the RFC. I wrote it down somewhere, and then let's see. There's an RFC where they basically gave the recommendations for ISPs giving out IP addresses to organizations and people. And you see, so let me try to bring that one up. I wrote it down somewhere.
Apparently, the number of
Maybe
addresses that exist
Yeah,
with IP version 6,
yeah, good one.
supposedly it covers every grain of sand on Earth.
Yeah, and it's really so. Yeah, look at this. I look at this. Look at this. This one is like the one I saw in a textbook the other day, and I was looking this up, and this is basically like a recommendation by IETF on,
I heard it covers every star and every planet in the universe as well.
yeah. I mean, look at this. Look at this. They say, well, 48/48 in the general case, except for very large subscribers. So basically, you're a small company, you go to your ISP, they'll give you a /48. It says, well, they'll give you a /64 when it is known that only one subnet is needed. Well, /128 when it's absolutely known that one and only one device is connecting. That would be like in a case where you're connecting from your hotel room using a modem or something
So
like that.
how does a /128 work?
So basically, it's just one single device connecting to a network. So let's say
Like, is that
you're using like your little dongle in your hotel room to connect to your, your mobile provider's network.
how many IPs, how many hosts can you have with a /20?
Just
Does that
yeah.
you can
So
have one?
that's only one.
Okay.
I think /28 loopback with IP version 6.
So that one is where that one /28 is the point,
All zeros.
yeah,
All
not
zeros
all
is
zeros,
loopback.
all zeros
Loopback.
with one.
At the end of it.
Yeah. So
Loopback.
this one, yeah. So you have ping
Colon, colon
colon
one.
one, yeah. So that's your loopback. So basically,
The,
yeah,
yeah, the other one is unspecified address.
yes. So
All
you're
zeros
right.
is unspecified.
Yeah. So all zero is unspecified address. So that is
But it
all
is a
zeros
but if
slash
you get a
128.
question on the test
Yeah.
that says is like all zeros a valid IP address for IPv6, it is a valid IP address.
It's
All
almost
zeros is a valid IPv6 address. It does search for another address, but if you get that question on the test, it's considered a valid address.
so yeah. Yeah,
Just
what do you
just a
think of
heads
that?
up.
What do you think of that, Sarah? You agree that it's a valid IP address?
Okay, I'm gonna have to break my silence, but I think I have come across a question like that.
Yeah.
So yes.
Yeah, well, yeah. So it's and when we talk about like the different types of addresses in IPv6, we talk about that. So there's a type of address called unspecified address, and then we'll talk about that. But I'm not sure if this one is like clear at all. Like, is this one clear to like Alex and Kevin and Balaram as to you get
Yes, it's
this one?
clear.
The first 48 bit, basically you get that from your ISP, typically. This this middle bit is the one, this middle 16 bit is basically the one that you use for your subnetting. So the
Yeah.
number of hosts doesn't matter because you have basically 64 bits to play with for every network. For every 65,000 network, you have 64 bits of, so think about that. You have 2 exponential 64. How many hosts can you have? Look at that. For every network.
Mm.
And that is just something you just received from your ISP for every network. So basically, the address bit doesn't matter. You don't have to start calculating. I need one of the reasons is this is that because we are so accustomed to IPv4, right? Where the whole
Mhm.
goal is to conserve IP address. The whole
Yes.
goal is, we have to use NAT and CIDR and VLSM, variable length subnet masking. Let's conserve this IP address, conserve it. Oh no, don't use too much, don't use too much, don't use too much, conserve it. That we're so used to, let's calculate the number of hosts that we need. We don't want to go beyond that. We don't want to give too much addresses on a particular network. But IPv6 is basically all you need to be concerned about is set what your networks are with this middle 16 bits, and basically the rest is the host on that network. So I can go like this one. So this is a single network now with this number of hosts on this network. Think about that. And then I can go, well, my second network is AAAA 1111.0.0.0.2/64. Are you getting it?
So on a /64, where is the subnet?
So think
The
about this.
the last one.
Where is the subnet? If you're talking about an IPv4 and you have your prefix, where is the subnet?
Okay, let me hit them with a
It's
question.
Yeah,
after
carry on, Sarah.
64.
Okay, I'm going to ask you for IP version 4, 172.16. David, can you type it?
Okay. Let's type that.
Yeah, 172.16.20 10 with a prefix of, let's say, 16, 17, 18.
Okay.
Yep.
Can you identify the network part, the subnet part, and the host part in binary?
Yeah, that would be basically 128.
I think you're pretty good. We will wait for Carrie and because they're not answering much. Yeah.
64. That would be like that's like a 64 host. That means you get 4 subnets. So that would be in the 16. That would be 20. That is the sub. So it's 17. 20 is the subnet. 172.16.20 is the actual subnet, and the first valid host would be 20.1.
Not really well. Yeah.
Okay, I'm just going to rehash that. So it's a class B address. That means the first 2 octets are the fixed octets, right? That is a prefix of 16. So 18 minus 16, you have 2 more. So those 2 would be your subnet bits. That is 2 to the power of 2. You get 4 subnets total. David, can you do this in binary?
I mean, this one.
11111 8 times. Dot 1111 again 8 times. Right, then 1 1 and the rest all 0.
Mm,
Yeah. The subnet bits, could you make it a different color?
yep.
No, just the subnet bits.
Just the subnet bits would be the 2 ones.
Okay, so
But
with
again,
IP version 4.
yeah. Carry on, sir.
Okay, so with IP version 4, we see now this is a class B address. The first 2 octets of all ones, that is in blacks, 16 bits, are for your network ID. The ones in red, the 2 ones in red which are turned on, this is your subnet part, right? So are we aware of the magical incremental number here? Do we know that?
4.
We know the incremental range over here is 64.
No, I don't know. Please elaborate that physical increment number.
Oh, with 64 hosts, 4.
Yes, the spacing between the subnets.
Wait.
Right?
No,
So
sorry. Not 64 hosts. I'm thinking slash 26 right now. Sorry.
Okay, so with IP version 4, what happens is that the reason you have started to do subnetting, VLSM, is because of the exhaustion of IP version 4 addresses. You have only a limited amount of addresses that were allocated to you by the gods of internet. So yeah, so that's the reason you started to subnet, and that's the reason they came up with IP version 6.
Yeah.
Right?
Yeah.
Now the same thing as David was trying to explain, as we see on the top, you have the first 2 hextets, I want to call them as all A's, and the third hextet is all ones. These are your network representation. That, as we said, that 172.16 belongs to class B. These belong. You have different kinds of addresses in IP version 6, like link local, I think. You have global unicast. You have anycast. So that's how in IP version 6 it's delegated, but not class A, class B, class C. No. Right. So with the first what David has written over there, it's all A's and ones. The first 3 is your network representation. The 16 bits that's
always, no matter what.
No, that is no. Actually, I have forgotten, but
it's not always, but most of the time. Because, for example, look at this recommendation again. So, small and large enterprises receive a /48, right? So typically, you from your ISP you get a /48.
Okay.
So then you look at it,
even if
you're a very large subscriber, they can probably give you a /47 or multiple /48. So the probability of you getting a /48,
you can technically subnet the rest of it if you wanted to.
Yes, you can, but usually you don't need to.
But what we do is usually use the next 4 for
Good one.
subnetting, and then the
Excellent.
rest is reserved for host.
Excellent.
Okay, so the reason I was looking at like you have to do it this way every single time, so it wasn't making sense. So now
Excellent. Yeah.
I'm understanding what you can do and what's recommended to do.
Excellent. Well, Kevin, is that clear? And Alex, is that clear? Or do you have
Yeah.
questions regarding that?
Yeah.
Is that clear? So basically, you get this typically, even if, I mean, look at this. Even if you're a home network subscriber, look at that. A home network subscriber, you get a /48. So the probability of using a /48 is really, really high. And basically, you only have to worry about, if you want multiple networks, about using the next 16 bits for your network, which will give you over 65,000 networks. And then you always, actually it's recommended to always leave the remaining 64 bits alone for your host. So like Sarah mentioned, these ones here are basically the ones that you've got. Balaram, is that clear? Kevin, come on, ask your question. Do you have any question regarding what's confused? Is there anything that you're like, I'm not clear about this one? Feel free, please.
I mean, what happens if you want smaller networks so you can manage them more easily, such as like for ACLs and stuff?
Yeah. So, but think about it.
Uh,
How many networks can you get from this again? From just that 16
So
bit.
wait, I'm sorry. For ACLs and smaller networks, I'm not getting that.
like instead of having the /64, like having /79 or 72.
So if let me try to understand the question. So basically what you're saying is that, let's say in a situation where you have a router to router connection, yeah, that what's the point
Yeah,
of, let's say you have a situation like this, what's the point of having, /64 between this guy and this guy here, right? Is that what you're
exactly.
saying? Yeah, but the thing, yeah,
Yeah.
again, it goes back to the point in that we're so much
You don't
used
have
to
to worry about it.
conserving, exactly, we're so much used to, we have to conserve, you know, IP addresses. Actually, I'm not sure if it's in this RFC, if it mentions point to point here. No.
Yeah, but at the same time, like
Yeah.
my mind is thinking that's
IPv4.
exactly what we thought for IPv4, and look what happened.
But this one is actually like what I said in the beginning. If you actually break it down, the
Yeah.
probability of us really running out of IP address for IPv6, it's really it'll probably take, like, maybe when, like someone put it, maybe even after the Terminators has taken over the whole world, Skynet is self-aware. And everything is destructing itself, or is
Yeah.
destroying itself. So basically, it's like, I'm not saying impossible, but it's extremely difficult to run. What's your opinion or thoughts on this, Sarah? What's your opinion or thoughts on running of IP address? Basically, like what Alex is saying is that's exactly the kind of thinking we had with IP version 4. That way, we're not going to run out of IP address ever, but we did. But with
Well,
IPv6, what's your thinking about it? Carry on.
I don't think we need to worry about that, at least not in this lifetime. It's not even implemented completely. Yeah, no, but like I said before, they say this is what I've read in so many articles, not just one, many places, that the amount of IP addresses that you have, which is like a squillion length long, it can cover every grain of sand on Earth. So probably a lot more than the population on Earth. Yeah. So I wouldn't worry about it.
Every planet and star in the universe as well.
Yes, Mark is all about the cosmos, so there you go.
Yeah. No, but I'm just thinking because like soon, who knows? Refrigerators might have IP addresses. Dog tags could have IP addresses. I mean,
So
the amount of stuff that we could
Yeah.
assign an IP address
but think
just
about this,
increases.
Alex. Think about this, Alex. So
Yeah,
refrigerators
Internet
and all
of
that.
Things is covered.
Yeah, but yeah, exactly. Think about this. You have 65,000 networks, right, on this one. How
Yeah.
many devices can you address on this one? On just one network, in the 65,000 networks, you can have this much addresses. Think about that.
Yeah.
So that's
I
in
see
just
your
one
point.
single network on the 65,000
Within
network.
so 65,000 times You can have
That,
that many
yeah, exactly.
addresses
So think
with
about that.
that
So
subnet
what will
mask.
you as a person, what else are you addressing? Even if you're addressing all the, like what he said, all the graves in the sand, why are you addressing? So that's one of the reasons why our mindset, there's a little bit of a mindset shift with IP version 6 because you're not typically concerned about hosts, you know, IP preservation again. It's more like you're subnetting to keep your network separate, not subnetting
Mhm.
because you're trying to conserve, but subnetting to say, okay, I need to keep this network separate from this network so that broadcast from this network will not get to that network and stuff like that. But it's not the goal again, it's not conservation anymore. So which is like the huge mind shift. Again, one of the huge mind shift is this.
Yeah.
This is a huge mind shift. Is that, let me write this down. IPv6 connected devices will have public IP addresses. Because IP version 6 as of now doesn't support NAT. So there's no network address
Yeah.
translation. So every single device that you have on IP version 6 connecting to the internet must have a public. So they can have, um, a local address that they use to communicate within themselves. But if they want to talk outside to the internet, they don't need to have like a private, range that's going to be translated to a public range. They have a public range that they use to communicate publicly, a private range to communicate privately.
Mhm.
So which is like the shift because to you in your environment you'll be thinking, oh, I have to use 192 suborders. No, every single device, it's having communication. It's having a public IP address basically. Kevin, you wanted to say something?
Um,
Yeah, yeah. Carry on,
I
Kevin.
just pulled up something.
Yeah.
I just pulled up something. Apparently,
Mm-hmm.
there are 820 trillion IP addresses,
Mm-hmm.
which is a plenty. But is that sufficient? Well, maybe not, because if Internet of Things becomes a reality, it may be possible for us to have 820 trillion network-enabled devices. And some estimates suggest that the Internet of Things,
Mm-hmm.
if implemented today, it would comprise approximately of 50 to 100 trillion objects. And that is just with our current population.
Mm-hmm.
So from 100 years from now, when you start colonizing other planets, like Mark is suggesting, yeah, I don't know, but we'll probably be gone by then. So don't worry about it. It's not our problem.
Yep. Yeah.
By then there'll be IP version 12. There'll be IPv12 or something.
But basically,
Right?
the summary of it is that we really, in our current generation and for multiple generations to come, we don't have to be concerned about conservation with IP version 6. That's like the whole summary of that. So in our minds, we must let there be like a bit of a shift when we're dealing with IPv6 than when we're dealing with IPv4. So that's like just one of the main points to realizing that every single device that you're using, you know every single one of them that's connected to the internet are going to be having public IP addresses. Okay, let's move a step further. So now that we understand this part in terms of like the subnetting side of IP version 6, does anyone else have any questions regarding the subnetting part of IP version 6 that we discussed today? Anyone? Kevin, are you okay with at least the basics? It's not as if you get everything at once, but at least you're okay like with
I'm,
the carry on.
I'm okay with what has been said. I
Yeah.
understand so far.
Yeah. Okay. What about Alex and Balaram and everyone? Is that part clear? Can we move on a bit now, or is there any question that still needs to be answered? So we can quickly
No,
answer
I
ones
think
that
I'm
we
good
have.
now.
We have Powell online now. We have Sarah online. Let me quickly read Powell's post because I don't like missing Powell's post. Powell's posts are always full of wisdom and
David, I'm just stepping away for 5 minutes. I will be back.
no problems. No problems.
Okay.
Yeah. Powell's posts are always full of like lots of wisdom and knowledge there. I don't like missing them. Okay. Uh 480001 greater than 65,000. Yeah, the loop back address and root aggression than smaller network. Yeah. So yeah, what Powell is saying here is that basically in IP version 6, rather than trying to go for because the other question, I think Alex, this also answers part of your question. I hope I don't confuse you more. What Powell is saying here is that rather than try to borrow from the 64 bits that you have for your host, yeah, rather than try to
Hmm.
borrow that and try to use that for network, you just do root aggregation rather than trying to make smaller networks. So what you're saying is that you just use as much because you have as much networks as you want, just use as much network as you want and aggregate the root rather than you trying to break the networks
Yeah.
down, you know, using like, I'm borrowing the host bit. There's no need to borrow the host bit anymore. Leave the host bit at /64, you know, you get /48 from your ISP, take the 16 bit in the middle, use it for subnetting, leave the host bit alone at /64.
And it's just because when I was doing the Netiquette IPv6, they suggested to do the subnetting, but to always borrow the entire hextet of IP addresses.
Yeah, okay,
You go from
actually,
48.
that one, I think there's a bit of like, because actually the recommendation by IETF is always leave your host at /64. And one of the reasons for that is
Okay.
that there are some protocols that actually require that.
Yeah.
Okay, yeah. What Powell is saying that extet nibble is 4 bits. So that means so it's possible for you to say, let's go back to the paint whiteboard. Let's go. Okay, it's possible for you to say, well, I want to borrow this one, yeah, this part of the host to use for my network. But if you want to borrow it, you have to borrow 4 bits at a time. So that's what Powell is saying in the
Yeah.
last one that says extet nibble is 4 bits. So basically, you have to
Yeah.
borrow
That's why.
4 bits at a time. But then again, the recommendation is to always leave the host bit as /64. I'm not sure where I read that, but I'll put that up. Let's actually try to put that up. Let me
Yeah.
so /64 um IPv6 host recommendation. I saw it somewhere where they actually recommended and said because some protocols actually require the /64 um, host. So for the host part, so just leave it as /64. Um, considerations for /64 prefixes. Mm, yeah, I'm sure I saw it somewhere. But yeah, we can look that up. I'm sure I saw it somewhere that, just leave it as /24, sorry, /64 for your host bit. And that one of the reason is because there are one of the protocols I remember now, which is something that we'll talk about very soon. One of the protocols that needed is something called stateless auto configuration, which is a way to automatically address. Thanks very much, Moise. I didn't look at the answer. So Moise has actually given the answer. Yeah, exactly. So that's one of the reasons. What Moise mentioned in the chat window called EUI64, or something that you can call like stateless auto configuration, which is
Hmm.
like a way to make IP addressing simpler on IPv6, actually require
Isn't
you.
the EUI64 used for the link local?
No, it can be used for link local, but it can also be used for the global unicast also.
Okay.
So actually, you can use it for global. So we'll talk about that very soon. So which is one of the reasons why it's recommended just leave your host part as /64. Because if you want to use those protocols that will make your life simpler, you need a /64 host bits.
In layman's term, what EUI64 does is you need to identify every device has to have a unique identification. So instead of manually going and configuring it, when you do it with EUI64, it takes a MAC address,
Yeah.
right? And there is this flipping of the seventh bit. It's a procedure that you actually learn as you go on.
Yeah.
Yeah, and that every device has a unique MAC address. It is going to flip it is going to flip the seventh bit, and append it to your network prefix, and there you have a unique ID for yourself.
Mm-hmm. Yeah. So what Sarah said now, I know may have confused some of us somehow.
Do you want to say it again? I will say it again.
but but it's something that we'll discuss.
Yeah.
It's something that we'll discuss and we'll build on. So what Sarah is saying is that so that's a way of simplifying um address giving out addresses in an IPv6 network. So you can simplify the giving out of addresses. So in other words, you have your network address, which we'll get to. You have your network address, and basically, due to some calculations, your host will actually address itself using its MAC address as part of the address. Because your MAC addresses are hexadecimal, right? Yeah.
Mac, yeah,
Carry on,
I
Sarah.
yeah, I guess binary.
Yeah.
It's about how many bits? That is 16. No, 816 plus 48 bits.
Yeah.
46, no, 42, 48. I forgot. I'm sorry.
Yeah.
Yeah.
That's right. Yeah. Powell's got the so Sarah, whenever just look at Powell's and Powell, it keeps us all on track, man. The guy knows. So Powell's got the answer in the chat window.
48 bits.
Yeah.
Okay. So yeah, it's just going to flip one of the bits. Okay, we ignore the flipping part now.
Mhm.
The whole concept is that every device has a unique MAC address.
Mhm.
So you are just going to assign the networking prefix. That is, let's say for the global unicast, you have the first for 64 bits are your that is your network plus subnet bits,
Mhm.
right? For
Yep.
global unicast, those 64 bits is what we will assign. The remaining 64 bits is going to yeah, your MAC address will determine what that will be.
Hmm. Yeah. Okay. Okay. Let's take a little bit of step forward. Actually, Powell asked an interesting question. Powell said, so the example that we were given in the beginning.
All right.
So
Do not
Powell,
ignore it.
yeah, Powell said, so what will be the last IP address of this of this?
No, the reason I'm asking them to ignore it for now is it's too much of information. It's overwhelming. They just need to get the concept for now that it is giving you a unique IP
IP
address.
address. Yeah. Yeah. Good one, Sarah. Good one.
Seventh bit, yeah, they will get confused right now.
Powell asked the question. Powell said, "Can we give the last IP address of this one?" So okay, let me go back before we actually do that, Powell. So let's go back to this one. So um, so from what we've discussed so far, so again, let me ask the question again. So Alex, how would you approach if you have a situation like this? From what we've discussed so far, so you go to your office tomorrow, they're like, yeah, we've got this new branch office. This new branch office going to be using completely IPv6, on the network. And the ISP has given us, this block of IP addresses. So what are you gonna do? Like, how would you approach that? So they've given you BBBB slash 48. So what would you do? How would you approach it now?
Well, I would make it /64 and I would put 0001,
Yeah,
that first network.
yeah, and just start counting from there.
Yeah.
Yeah, good one. What about you, Kevin? What would you do in terms of this one?
I I agree with Alex.
Yeah, good one.
The
And
easiest way
Banram,
to do
yeah, good one. Okay. Yeah, so I realized I'm not sure. Is this one actually? I don't think your ISP will give you because if they were to give you /50, then that means they have to give you um you know two more. No, it won't be. That won't be right. Power is what you're trying. What Power is trying to say is that won't be right, right? Power is that what you're trying to say that this is not right? /50 is not right because we can only borrow four. We can borrow 4 bits from the next extet, as
You
Sever
said
put
it's
it.
right.
Is it right? Because okay, if I've got /50 now, then that means this one will be. So if we write this one out, so what we'll have is we'll have a 0000. Let's expand this one. 0000 0000 0000. Okay, so this is what we'll have. So basically, we're talking about /50. So this /48 /50 will be half of this one. So we're not borrowing this whole 4 bits. We're only borrowing 2 bits from this. So is that allowed, Powell? Is that what you're saying? That so why not /50? Okay, it's easier to subnet without breaking nibble. Okay. So what would be the last IP address of this network then? not the last IP address though, because we have to what will be the first network that you can use on this one. So if you have something like this, what will be the first what will be the first network that you can use? So let's try to do this together and then move forward a bit. So what do you think, Siva? What will be the first network on this one?
Okay, I'm a bit lost, but let's just do this.
Yeah.
The first octet would be hextet would be 16,
Mm-hmm.
plus 16 would be the second, that is 32, and then plus the third one would be 48, right? And we are looking at 50.
Yeah.
So 50, 48, 49, 50. So can we just split the fourth octet down in
So yeah, let's
binary
break it
now?
down. Yeah. So we go one one
So that
one 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 one
eh,
one. Oh, sorry. Let's break it. Sorry. Let me break it down. Zero 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 zero. So that is this fourth one. So we want slash 50.
50. Freaks, I'm getting confused right now. It's been a while I've touched IP version 6, but okay. Um, First will be what's he writing? A 0. Okay, one sec. Let me just recap this. If
Yeah.
it is a value of 3, then it would be. Hmm.
So let me try to. So if I try
But
to this one also. Yeah. Carry on.
but earlier when you guys were talking, didn't you say that whenever you're borrowing, you only can borrow 4 bits at a time? So if you are going to do this, which is the slash 50, it will be the three A's and then 0
Yeah. I
and
think.
then whatever number after.
Yeah. I think the way I put that is wrong because it's not as if you
Shouldn't
can't
it
borrow it, but it
be?
makes it easier if you borrow 4 bits at once than if you borrow
No.
just 2 bits from. For example, if you borrow 4 bits at once, you don't have to be breaking this one down to try to understand what's the first network. I'm not sure if that's clear. Is that clear,
Okay.
Terry? Yeah, but if you
Oh,
borrow just 4 bits, it makes it simpler than if you're borrowing 1 bit from this one.
oh,
Yeah.
okay.
Essentially, it's best practice.
Yeah.
Oh, okay.
So with this one, so what would be the first one? So now this 2 bit also belongs to the network. So we have this other 2 bits belonging to us. So we can say 0001 will be the first network. So what would that be? So I'm not sure if that is that clear, Sarah? Or what do you think? Or am I right or am
I'm
I
sorry,
wrong?
I'm having a brain freeze moment right now.
Yeah, I
Honestly.
Yeah, IPv6 can do that. So I think so in my own thought I could be wrong, but correct me if I'm wrong, guys. I think because this
But
two belongs to the network because it's slash 50, so we are breaking down this middle for this middle extet is what we're breaking down. This one, the fourth one. So breaking it down, this two because it's slash 50, this two belongs to the network
alright.
part. So the next network will be 00 actually, not 01 because 00 can also be used. So we can use 0000 and then the next one will be 0001. So our network will go this way. Our network, if I get it right, our network will be AAAA, 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 then 0000 will be the first network. Then the next network will be this. The next network will be um, AAAA, 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 0001. That'll be the next network. So this will be the first network. This will be the second network.
Wouldn't it be 4, not 1?
Wouldn't it be what?
4.
So actually, this one will be. Let's see. So again, we may have forgotten. So here's one
Because
of the things that could be confusing with IPv6 because the mistake I'm making now is I'm treating these ones as one characters, not
Hmm.
4 bit.
Yeah, yeah.
Yeah. So I'm treating this as like 1 bit, not 4 bit. So basically, going back to this one. So this one will be, if I put all this one together, so this one will be one exactly. So let's go back. So this one will be one, um, 000. So then the next one will be AAAA because this one will be one. So move this one 01. Next one will be 11. So 11 will be 1 plus 2, which is 3, right?
Are we
So,
talking about subnets now?
yeah.
Yeah, so
Eh,
shouldn't it be
eh,
left to right? Shouldn't it be 01? I'm confused, to be honest.
Yeah, because it's 48 plus 2 would be 0, 1, 0, 0, 0, 0.
It's 0001, and then it will become
Yeah,
11.
0001. Yeah, then 11. So
Yeah.
next one will be 11 is what does 11 equals to in this term? So 11 will be equals to 3, right? Because 1 actually represents 1, right? But then the other 1 represents 2, right? In terms of bits. But
So each bit is each.
so the bits are different. No, remember that the bits are different. The bits are 1,
Each of them is
2,
4 bits,
4.
right?
Yeah.
So
No, the bits are 1, 2, 4.
8421,
Yeah,
yes.
sorry, 8421. So that means if we got 0001, this equals to a 1. If you've got 0011, that equals to a 3.
Yes. Yes. I've forgotten.
So that's a 3000. So Powell, are we right? Is that right or wrong? What do you think? So first would be A0. We cannot use Powell says, okay, yep, good, good one. There. So let's look at Powell and Moise's comment in the chat window. So Powell says we've got first to be A0. We can use 0, not like in IPv4. David is still easy. Thanks very much, Power. Here's your answer: 0001 first and 00FF last. Okay, yeah. So that's 0000 to 3FFF. Okay, but Powell, how is that right? Because we can't use the first 2 bits, remember? We can't use the first 2 bits of this. I'm not sure if we're confused because we can't use the first 2 bits because these first 2 bits are part of the network because this is a /50 that the ISP gave to us. So that means we can't touch this 00 also. The only thing that we can touch is these two. We can only touch these two. We can't touch this 00. We can only touch this one and this one. So am I right or am I wrong? Yeah, exactly. So we can't touch the first 2. We can only touch it exactly. So that way, that will give us 0, 0, 0. Then we go 0001, 0010, 0011. So first is 3, exactly, good one. Yeah, exactly, which is basically the one that I was mentioning here. So next one will be 3. Then if we break it down that way, we'll get like the final one. So you're right.
Wait, is that the first one? Okay, okay.
Yeah, so the first one, the first network that we can use on this one is this one, the 01. The next
Okay.
one will be 1 because with this
Wait,
one you got
0, 1? You mean 100, 10?
no 1000. This one.
Yeah, that's the first one.
That's the second
That's the
one
first.
because we can
That's the
also
second
use
network.
yeah because we can also use the 0 network. We can use
Okay.
00 also. Then after 00, the next one is 01. So
Okay.
01 gives us 1000. I'm not sure if that is clear. Again,
Wait,
remember.
I'm not clear. Sorry, I'm not
Again,
clear at all
remember
right
that
now.
remember that when we're talking about this one, every single character is 4 bits.
Yes.
So
David,
basically, carry
I
on.
have a suggestion.
Yep.
Yeah, I think we could just take one example where we just basically concentrate on the conversion from decimal to hexa. Like, for example, the global unicast address
Yep.
is 2000/3. If we can just demonstrate the beginning and the end, I think it is 2000 to 3FFF. If we can just figure out how that works, then this whole conversion process gets easier to understand.
Okay, let's do that. So let's
Okay,
go this
yeah.
one. So which address are you suggesting?
This is the global unicast 2000.
Yep, 2000
It has a prefix of /3.
/3. Yep.
Yeah. So let's break this down. And
So all global unicast addresses start with 2000?
yes, and they end with 3FFF. That's the highest possible address that you have for global addresses. Right? David, could you write a 3FF? That is the ending.
Okay, so that's 2000.
Hyphen FFFF. Yeah, you should probably put in a hyphen there.
Where's that?
in between 2000 and 3FFF. That is the range of your global unicast addresses, right?
And that is slash what?
The global unicast addresses have a prefix of 3. Okay, now let's just try and break down 2000 in binary first.
Okay, so 2000. So basically, if you've got 2000, this one. So if we expand that first, right? Should we?
We will expand that first, yes.
Yeah.
Now, we remember each of those octets are consist of 4 bits. So the bit value is 8, 4, 2, 1.
Yeah.
So when you say 2, that will be 0, 0, 1, 0. Okay. Can you give a space? 0, 0, 0. Yeah. Right.
So basically, again, just to reiterate, this 2000 that we have here, if you actually break it down, this is what it translates to, because every single character is 4 bits.
Can you give an arrow over there, like hyphen hyphen, and that whatever that character is called? Yeah, and just put in 2 there. 2. Okay. Next line.
So this is for the 2000, right?
This is yeah.
Yeah, this is for the 2000.
Okay, now let's do
the next one is basically all the rest are 0, 0, 0, 0.
Okay, one moment. No, that's correct. I'm just looking at
IPv6 is such that it's
okay, can we go back to
sure.
I can only see myself. Right. So that is 2000. Sorry, just give me a moment. Absolutely, yeah. 3FFF. That is the ending range. So we break that down as well.
So does anyone want to volunteer to break down 3FFF for us?
Jerry is there. Hi, Jerry.
Anyone else?
I can do it.
Yeah, carry on.
All right. It's going to be 0, 1, 0, 0. Wait. No, 0, 0, 1, 1. Sorry.
So how did you get 0, 0, 1, 1?
Because that equals 3, I believe.
Yeah, because you've got 8, 4, 2, 1. So
exactly.
Kerry and Alex, is that clear or is that confusing?
Oh, I got that.
Yeah, I'm getting it.
Yeah. So basically, every single character is 4 bits, and you have to break them down. That is, if you want to like do extreme. So you see one of the reasons why you just want to keep it simple, and just use slash 64.
So now, yeah.
Carry on.
Okay, and then basically 8 plus 4 plus 2 plus 1 equals 15. So the letter value F is worth 15. So it's all 1111.1111.1111.
And this is equals to 3FFF.
Absolutely. David, the one more thing probably they should always remember is 1 to 3, 1 to 9 is in digits. When it comes to 10, that is A, followed by B would be 11, and it goes up to 15, I think, or whatever.
Yeah.
So you should always probably have a table out there that shows this.
Yeah.
Yeah, F is the highest letter. So if you see like an address with like W or Z, you know that's an invalid address.
Yeah, it goes up to F. So you start off with 10, which is A, until 15, which is F. Are the rest of them okay with it?
Okay,
yeah.
Now, okay, one more thing. When you say a prefix of /3 over here, what does that mean? If you see below 2000, the first the first octet, the first 3 bits, these will remain fixed. So for every global unicast address, you see the value, it adds up to 0 plus 0 plus 1 plus 0 gives you a value of 2, a decimal value of 2. These 3 bit values will always remain fixed for a global unicast. Now, if you just to give you an example, we have also link, what is that called? I forgot.
Link local.
Link local, right? I think it starts off with link local unicast FE80/10. David, could you write that down?
Yep.
FE80/10::/10. Right.
What is this local unicast?
This is link local unicast.
Link local unicast.
Right. We will just break this up. It will get easier for you to understand the conversion. Okay. So F would be all ones.
E
in decimal. Yeah. Right.
Would be 1110.
is it?
14.
So we have 8421. So that is
8, 9.
E is 14.
Yeah, probably
Yeah.
1110.
Good one.
Yes.
Yeah. Good one, Kai. So Alex, what about H?
Pardon?
What will 8 be?
F?
8. So we're breaking this down. FE80.
Oh,
8.
8. 1000.
Good one. Excellent. And then 0.
Okay, so now can anybody tell me what /10 prefix, how many bits would be fixed? Just ignore the concept of what a link local unicast means. Just think of it like a class A address. You have the first octet fixed. Similarly, for this one, you have /10 prefix. So you have how many bits fixed?
10.
Yeah.
All right.
10 bits.
So that is
Okay, so that would be the first octet is 4 bits, second octet is 4 bits. Yes, absolutely. Probably you could highlight it to a different color. There you go.
yeah.
Easy peasy.
Good one. Let's make a bit of progress now. Okay, let's just quickly talk about like the types. Cause we've all been mentioning like all these different types of global unicast and all those type of stuff, and it's just right that we discuss them a bit. So let's talk about types of IPv6 addresses. So like IPv4 addresses, we have different types. Like IPv4 addresses, for example, we have something called the private range, right? The private range are ranges that you cannot use on the internet. It's something that you can use on your own internal network, but you can't use on the internet. And what are those ranges in IPv4?
Class 10.0.0 to 10.16.0.0.
So 10 dot what?
10
Yeah.
0.0.0 to 10.16.0.0.
Slash what? I can hear you, Balaram.
Hello.
Balaram, you want to type it?
Yeah. 10.0.0.0
Mm-hmm.
to 10 dot
Yep.
dot 255.255.5.
Yep. Good one. Yep. And what's the next one?
That is 172.16
Yep.
.0.0.
Yep.
Then up to 172.31.
31.
Yeah, 31. Private .255.255.
Is it 31?
Yes.
Yes.
And what's the subnet mask?
Subnet mask of
Slash what?
I don't know.
Slash 16. Let me help you. Or slash 12.
12.
Class
It's 12.
Which one? 12 or 16?
12.
12.
12. Yeah, you're right. Okay. And the next one?
192, 168.
Yeah. Yeah.
Up to 192.
So 192.168. And what's the subnet mask? What's the subnet mask?
I think Owl keeps muting Belram.
Ah,
It's
okay, yeah.
16?
/16 or /24?
16.
16.
16.
Why?
these-
For class C and
So,
16.
so these private ranges are classless. Is that correct?
It's up to you because the way you want to use them within your network. No one cares when they're not routable on the internet.
Well,
And,
that's why I guess. Okay, but like by looking at the subnet mask, you could say that's a classless address because a 192 would typically have to be a /24 if it was a class C. But since it's a /16, it's
yes, these are the ranges. David, that's 16. Yeah, for
Yeah,
class C.
yeah. Okay, so the same way IPv6 has like these types of network. For example, one other type of network on IPv4 is something called a loopback address,
Mm-hmm.
which is what? What's the loopback address? 127 dot.
Anything.
Yeah, exactly. 127 dot anything. Yeah. So basically, the same thing for IPv6. We have all these types. So number one type is what? Who wants to give us the number one type of network in IPv6 so that you will understand them a bit? So number one type of network in IPv6, what's it called?
Global
Um,
unicast.
yes, you have a global unicast address first, which is
Global
routable.
unicast address. So what's like the characteristics of a when you say global unicast address, what does it mean?
That it's routable on the internet.
Good one. So you're talking about like your normal IP addresses, like in IPv4, like you have an IP address of 11.2.2.2, whatever. So it's routable on the internet. Yeah, what other characteristics?
Your public IP addresses with IP version 4.
Yeah, so it's basically the equivalent of your IPv4 public IP addresses. And what other characteristics? What other characteristics? Global unicast addresses. What other characteristics?
Starts with 1,000 or 3,000.
It starts with okay 2000, just what we just did before. So yeah, the global unicast addresses start with 2000 and have a prefix of /3.
2000
And wait,
/3, okay.
okay. So if you want in binary, I can give it to you, but the range is from 2000 to 3FFF. So anything that falls in between that is your global unicast.
So 3FFF. So you're referring to the very first octet, right?
Yeah, it would be
Octet, sorry.
yeah 001, like I said before, the fixed fixed bits,
Yep.
followed by all zeros.
So the 2000 : through 2000 FFF all the way through.
Yeah.
Mhm.
Does that make sense? Okay.
Yeah. Okay. So good one. So that's a global unicast. What other types of addresses do we have?
Link local.
Link local. Good one. Link local type of address. And what's the characteristics of the link local, or what does it mean when we say we have a link local IP address?
Wait. So, the 3FF, how would that look, that address? The last address. What's the last global unicast address look like in entirety?
0011 00 followed by all ones.
So
Okay.
again, the
You know
last
why?
one doesn't really matter. What really matters is this. You go to
It
your
starts with
ISP.
3FF.
Exactly, that's what matters.
Okay.
Because
Okay, so it's
you,
three.
when you say 8421 and it's starting with 3. So 8 plus 4 is 12. So you chuck that out. 2 plus 1 is 3. So that's why 0011 followed by all ones.
Yep. Is that clear?
Okay.
Yeah. Okay, so what about the link local address? What's the characteristics? What do we mean when we say we have a link local address? So actually, I'm missing a lot of chats in the chat window. I would say that before we. Yeah, okay, yeah. Good one. Okay, yeah, good one as usual, Power. Okay, globally unique. Yeah, thanks very much, Moise. So Moise gave another good characteristic of the global unicast. So they are globally unique. That is, there's only one of it on the internet. Globally unique. Okay, so what about link local?
Internet. Yeah.
Yeah. Okay, link local addresses. What does it mean when we say link local?
Link local are yeah.
Well, it's equivalent of
They
169.254.0.0/16.
Which one is that? Okay, yeah, you're saying equivalent of 169, right? Is that what you said?
Yeah,
Ah, okay. Of the 169. What's the one?
169.254.0.0.
And what's the 169.254? What type of address does that mean?
It allows you to devices,
yes.
Allows you to what?
speak with directly connected devices.
Good
The
one.
link.
Good one.
Yeah. You are only using it on the on a link. A link, yani you will be connected to another router from your interface to the interface of the other router.
Yep.
So that's all. It doesn't go beyond that.
Yep. Good one. And what else? What are other characteristics of link local?
It is automatically configured as soon as you configure a global unicast address.
Physically configured. Yeah. What else? What about like the range?
Automatic.
But can't you turn that off? The auto configuration.
We can.
So I guess I'm not sure. I haven't worked on it much.
No, I like the thing is actually like the thing with auto configuration or with that is that once if you switch on, at least from my own understanding, you switch on IPv6, it gets a link local address. It always has like two addresses no matter what. It will have one link local address and it will have one that will be the address that it uses to communicate with the internet.
But
So when you're talking
for the
about IPv6,
routers,
yeah. So when you're talking
the,
about IPv6
sorry,
auto config, you can
yeah.
turn off, from my own understanding, you can turn off auto configuration for the global unicast address because that also can be, you can use, IP auto config to turn that on. And basically, the device will address itself automatically with a global address. But the local part of it, you don't need IP auto config to turn that one on. It's on by default. So that's my understanding. So is that wrong or is that right?
Um, no, it gets automatically. Yeah, you have a link local address when you configure a global unicast address. Whether you can turn that off or not, I'm not sure. I can confirm it afterwards for you.
Well, I'm pretty sure on Cisco routers you have to configure it for it to do the auto configuration, or
So
you can manually assign.
so when you're
But
talking
PCs
about, yeah,
themselves,
so when you're talking about auto configuration though, there are two things to note. Is that you can use auto configuration works for link local, right? But you can
yeah,
also use, so if the command that you're referring to is IP autoconfig, IPv6 autoconfig, if that's the command that you're referring to, that command is to turn on auto configuration of global unicast addresses, not for link local. Because actually, I did a lab of that one before we started. And what the result of the lab is this. I go to my device, I enable IPv6 on that. It gets a link local address by itself. Then I enable IP autoconfig and then configure like a network address on one of the interface using AUI 64. Then it automatically gets the global unicast address. But again, okay, what you're talking about um, is there a way to turn off the link local part of it, right?
uh, well, for I'm pretty much saying that it doesn't always have to be automatically configured. That it's not always on by default. That PCs will have it on by default just
Yeah.
because they're stupid. But
Mhm.
um,
On a Cisco
routers,
router, yeah.
the Cisco routers, you can choose how you want it to do it by the commands that you type.
Actually, let's bring that up. Let's quickly have a test of that one. So
Yeah,
because
David, I'm just stepping away for 2 minutes, okay?
yeah, no problem. Yeah, let's quickly bring that up. So I'll bring up two routers here. I've got a router here and I've got a router here, and I've got, let's give a switch in between them, and let's just connect these two to a switch. So you got this one connected to this switch, and you got this one connected to this switch. Let me show all the labels so I can know what's connected to what. And let's switch all of them on. And then let's quickly find out. So what we're trying to do is find out if the link local addresses, if there's a way that is switched up. Or so so if I go interface E00, um, actually, sorry, my bad. Interface E00. How do I turn on IPv6 on this router?
IPv6 unicast routing
IPv6 unicast routing. And where do I enter that?
in global configuration.
Is that true that that is how I turn on IPv6? Is that really true that that is how I turn on IPv6? So are
That's
you
how you
saying
turn
if
on.
I don't type IPv6 unicast routing, I cannot use IPv6 on this interface?
I think it's a global command, and you probably have to type IP routing or IP enable. I forgot something.
So what you're saying is that if I don't type that, I can't use IPv6 on this interface.
Mm-mm-mm.
Yeah.
I can't. Okay, let's try it. So if I go IPv6, yeah, the command doesn't
Uni-
even exist. So why doesn't the command exist?
Global. It's a global command.
No, I'm talking about I want to give this interface. I want to prove that. So I want to give this interface an IPv6 address, but I can't even type in an IP address. What's going on?
Because you're in the interface configuration mode.
Yeah.
Yeah.
So I
You
want
want
to.
to enable, I think you have to enable IPv6 in global
So
configuration
that's
mode.
what we want to prove. We want to prove that do we really need to enable it in global config to be able to use it? So that's what we want to prove. So the way to prove that is we want to give this interface an IPv6 address. But I'm trying to give this interface an IPv6 address, but it's not allowing me. Why?
IP version 6, you're missing the V6.
Okay, IPv6. Yep, nothing is happening.
Yes.
Why is that?
Oh,
To go back, you need to go back one step.
This is
No, he's trying to
this is
show.
this
He's
is
trying to show it,
no.
Mark.
yeah. This is the one that we're discussing before in the switching series. Remember, any layer 3 multi-layer switch port by default is a layer 2 port.
Oh, okay.
So that's
Yeah.
so that's the reason. I know you were thinking something complicated, but yeah. So you see now I've got IPv6
Wait, why did you have to do no switch port?
because if you're referring to a layer 3 switch, by
Mm-mm.
default every port is in layer 2 mode.
Yeah.
So
Oh,
you have to use no switch ports to put it to layer 3 mode. Otherwise, you won't be able to configure an IP address for the interface. Okay,
okay.
so let's do IPv6 address, right?
hmm
And then what? Let me do IPv6 address auto config. Now, I'm not turning IPv6 on globally using IPv6 unicast routing, am I? No.
No.
I'm just giving, I want to say, I want you to get your own link local address by yourself. So look at this. I can either type in a link local address this way, or I can say, I want you to just configure, you know, this by yourself. So I go IPv6 address auto config, enter, and then if I go back and I do a show, how do I see the IPv6 address of this interface? Let me make this
Show
better.
interfaces?
Show, okay, let me make this so that we can all see it
No,
clearly.
show IPv6 interfaces?
Good one. So let's go 14, apply. Okay, show IPv6, yep, interface E00, right? and then I can see that I have a link local address. But I didn't have to turn on IPv6 globally to get this address. I've not gone into the config mode and typed in IPv6 and typed in IPv6 unicast routing. This one. So this command does something entirely different. What this command does is to allow directly connected networks to be routed. But I don't need this command to use IPv6. This is enabling not IPv6, this is enabling unicast routing. But again, that's not like the thing that I wanted to prove. What I want to prove is to prove the link local. Can we switch it off, or is it something that it has to be on all the time? We can't do anything about it. So let me go and change this to 14.
So what we want to do is configuring. So what we're saying, you said it automatically creates a link local. Can you display that for us?
Yeah. So let's go no switch port.
Because that's what you guys were. That's what you were
Show
saying.
Yeah. Carry on. Sorry.
So is config by default enabled? Is auto config by default enabled?
On the interface, no.
Like, what if we didn't go in there and do anything?
It is by default. David, could you just give assign IP?
Sorry, I didn't get that, Sarah. Sorry, I didn't get that, Sarah. What did you say?
No, can you assign an any interface?
Interface E00. Yeah. And what should I do? What do you want me to do to that?
Yeah. Yes. IP version. IP. Yeah. Okay. Just put in anything. 2001.
Yep.
Yeah. Address. 2001 colon DBA.
IPv6 address.
Oh, yeah.
2001.
Colon D anything DB8 colon 20
beef
21 colon again colon 21 1111 colon 1.
We can use colon.
Oh, no, you can't have two double colons.
So shall I remove this one?
You can only use. Yeah, you can only use that one time.
Yeah, just once. Towards the end. Yeah, you can remove this. You can remove the one after 2001. Yeah, you can just have a single one. And towards the end, yeah, double colon and 1.
1. Yeah.
Enter.
Incomplete command. Because it needs the mask.
You need it. You don't need a mask, huh? You don't need a subnet mask.
64.
Yeah, you don't. I guess
I don't know.
Yeah, can you do a? Could you do a question mark? And yeah, okay, try it.
Yeah, you want a mask because it needs a prefix.
Yes, so 64. Okay, 64.
64. Yep.
Okay, so now we go back and see show IP version 6 interface brief.
So you see, it got this one by default.
Yes, a link local address will start with
FE80.
FE80 /10, like we did before, where we converted it to binary.
Yeah.
FE80.
So
that was
again,
all
it looks like this one comes by default no matter what you do. So as long as IPv6 is working on that interface, you get a link local IP address.
Yeah, anytime you have an IPv6 address associated with a port, then you're gonna get a local address.
A link local address, yeah.
And is that using EUI64? How does it do that?
So
What is it
yeah,
used
it
So,
does. So that's
That's
one of the
yeah.
other things that we'll talk about. So it does use. So we'll explain that because I don't want to confuse people by saying
so
EUI64.
probably you shouldn't be jumping into that right now because
Yeah,
it's
exactly.
uh
So we'll
yeah,
talk about that
you can have a
another
go
time.
into
Yeah.
that. Yeah,
Yeah, I'm not ready to explain it myself, but I just know it splits it
I
down, it
think I
splits it in the middle and adds changes the seventh bit
So basically, what you
from
need
a
to look
zero
for
to
is look at this. You see
yeah.
FFEE right in the middle here. And if I go to show interface E00, sorry, my bad. This is the MAC address of this interface,
yeah, it's that. No,
AABBCC00.
just doing a
Now,
little
if I
class.
scroll up and you see this
It's not
one,
a class, it's a hangout. It's a
so you
Google
have
Hangout. IPv6.
so you have A8, BB, CC, then you have FFEE in the middle, then you have 0010. So basically, look at this part 0010 and look at the MAC address of this device.
Always when I used to practice my labs with
Yep,
IP version 6,
yep,
it's because it has so much to do with MAC addresses.
yep,
So I would configure my own MAC addresses. Like you can just go to the interface and say MAC address and give a very simple one, like
yep,
000.1111.1111
yep,
dot yeah. So when you start analyzing these show outputs, it's very easy for you to understand
yep,
rather than what's assigned.
yep. So, sorry, my bad.
Also, I think link local addresses are used because I think Mois is his name. I'm not sure.
Let
He
me
was
let me
asking
see
me.
that. Let me see. Sorry. Let's see. Okay, yeah. Okay, Power says you
No,
can
no,
enable.
no,
Yep.
not Mois. The guy who was speaking before. He was asking if you can turn the auto configuration off for link local addresses.
For link
I,
for link local
yeah,
IP addresses. Yeah.
yeah. When you I'm not sure about that because I think link local addresses are used as the default gateway addresses for the routers with IP version 6, and also it's used for neighbor discovery and all that ARP thingy that you have with IP version 4. So I'm not sure if you can turn it off. I mean, we'll have to look into it
Yeah,
more.
so actually, what Powell is saying here, Powell said as soon as you have IPv6 enabled, you have at least link local address on that interface. So link local address is not something that we can switch off because once you have IPv6 enabled, you're going to have link local address on that interface. Yeah.
Even the routing protocols use link local addresses to IP version 6 link local addresses to establish the adjacencies between them.
Yeah, it says
So
can be used by applications just like a regular global unicast address. You could, but routing protocol would not work. Yeah, IPv6 stack in global configuration is not enabled. Yeah, exactly. So that was what the other thing I was bringing on is that IPv6 stack in global configuration is not enabled by this command. So this command is doing something completely different. So when you say IPv6 unicast routing, that is not to enable IPv6. That is to enable routing of directly connected interfaces. So normally if you have an IPv4 router and you have 10.1 on one side, 192.1 on one side, you can ping between those two networks by default because it will route directly connected networks. But on IPv6, it's not going to do that by default except you have this command, IPv6 unicast routing. So this
mm-mm.
command will now allow it to route directly connected
Route,
interfaces. Yeah. So it
yes.
is not, so this command is not to enable IPv6, it's just to route, to enable it to route directly connected interfaces. Yeah. Okay. So let's make some progress. So the link local one. So basically to explain this to Kerry and others. So basically you have your network like this. Let's make it simple. You have your network like this. Let's copy this one and then we'll probably, yeah, I think we're nearing the time that we'll finish for today. But let's quickly, so we'll copy this one. Got my wife here. Sorry. Okay, so let's go Control V, and we've got, you have your router here and you've got your router here also. So inside your network, you have like maybe your little switches connected here. Um, and the way link local addresses work is this, and you have your devices connected to all this network. So you have a device connected to this one, a device connected to this one. So the way link local addresses, the way link local address work is this. IPv6 is enabled on this machine, so it will come on and give itself an IP address in the range of FE80. This one will come on and give itself an IP address of FE in the range of FE80. Yeah. So
Yeah.
yeah. So what happens is that they give themselves these addresses in the same way that the APIPA addresses, automatic private IP addressing, the 169.254 work. So they don't get any addresses, they just give themselves addresses. So they give themselves these addresses and then they can use these addresses to communicate between each other. Because they are both on FE80 network, they can talk to one another automatically without anybody configuring an IP address. So the concept is that in IPv6, by default, they will get this no matter what you're doing. And any communication on this local network, they will use that. But then the issue is if this guy is trying to send a packet outside the network using a source IP of FE80, a router cannot route anything starting with FE80. A router will not accept that and route that. A router will always drop that.
Like your private addresses for
Yeah.
IP version 4.
Yeah, like your private addresses. So you basically drop it. But it's something that machine can automatically give themselves. Like if I go to my machine on my PC now, I will see a link local IP address there, even though I've not configured anything. And it's just something that it has given itself so that it can communicate with other devices on its network. That's just basically what link local IP addresses mean. So let's move on from link local. What other type of addresses do we have? There's another one that is similar to link local called site local. What does that mean?
Uh, isn't it called unique local?
Unique
I
local.
They
think
they've changed the name for that
it's
one with
deprecated. Site
Ah,
local, I believe it's deprecated.
so that's
Yeah.
old school.
yeah.
So let me see. So what's it called now?
It's unique local.
Unique local.
I must have been reading some whole textbooks then.
Yeah.
Yes, it's there. In the RFCs as well in the old textbook, like Rick, what's his name, Grazini.
Yeah.
They still have that.
Yeah,
Yeah,
the book I was
Yeah.
reading is The Network Warrior, the one by this O'Reilly people. Really good
that's
book.
quite cool.
Yeah.
Yeah.
I think it was deprecated fairly recently.
Very
Ah,
recently.
yeah, yeah. So yeah, so the unique local. So what does it do? What's the point? What's the purpose of that?
Well, it's equivalent to the private IP
So
addresses that
okay,
we
hold on.
have.
What you're saying is that the unique local is irrelevant. It's not relevant anymore. Is that what you're saying? Or is it that the name has changed?
Well,
Or
it's equivalent, so essentially you can use it within your network
hmm?
to route within your network, not using the link local, but it won't be able to travel onto the internet.
Good one. Good one. So in other words, let's try to break this down. What is being said is this. If you've got like your link local addresses, right? If this one gets to the router will basically say anything starting with FE80, I'm not passing it, I'm dropping it. But you can have another type of address called a site local, which means let's say you have another internal network here, and this internal network you want to be able to communicate within your network, but routers by default will drop FE80. What you can
Yeah.
do is use your site local addresses, which will basically get passed between the routers, but it won't get passed to the internet. But it will get passed within the routers on your site. So that's why this one is called link local. That is
It,
local to this link, and site local before, sorry, deprecated now, but it's local to the old site or unique local. Carry on. Sarah wanted to say something.
so I was just about to say that yeah, the keywords that you look for with
Yeah.
unique local addresses are
Yeah.
that sites, in between sites, they
Mhm.
are independent of the ISPs.
Yeah.
So when you say ISP, Anna, you're shooting off to the internet that is
Yeah.
routable on internet.
Yeah.
Link locals would start off with FC00 with a prefix of 7
Yeah.
between sites but not globally routable on the internet.
Yeah, good one. So basically, let's actually clarify that also like a bit. So if you've got your, let's go back here. If anything starts with um, FE 80 or FE8, FE9, FEA, FEB, that's your link local basically. Anything that starts with
Yeah.
FE8, FE9, FE, FEB. The unique local Well, I used to know it as site local, so this could be wrong because I've been reading whole textbook apparently. So,
Okay, yes,
so
in
this
that
is
case,
FEC
no,
um FED.
F FC00 colon 7 to FDFF.
Is it true? Because this is the one that I know of. I mean, the textbook. I've been
No,
reading some
no,
serious whole
Powell,
textbook.
Powell has confirmed that, so
Yeah.
yes.
So this one is the one I know of is FEC, FED, um, FE, FEE, and FEF
Probably with site local.
for unique
I'll
local.
confirm
I
it
mean,
after. The unique local would be FC00 to FDFF,
to
prefix of 7.
FDFF. Can anyone else
Yes.
confirm this? Because I'm not too sure.
The one I can confirm. Okay,
Yeah.
you want me to check that?
Yeah.
RFC? Okay, one sec, please.
Um,
I think it was appreciated in 2005.
You're
um,
looking for. You want me to check for
Uh,
okay.
I posted the RFC, I think, in the chat.
okay. Sorry. Good one. Thanks very much. Obsolete. Yeah. Oh, okay. Yeah. Sorry. Yeah, that's one other danger in 1990. You're reading some whole textbook. You think you've got some accurate knowledge.
Well, the IPv6, it just changes so frequently that it's
Yeah.
Yes.
kind of hard to
So,
follow.
okay, so that's obsolete now. So basically, it's the one that Sarah mentioned that's accurate. So forget my FEC, FED, FE. So that's gone.
Well,
So
it's still FC,
yeah, it's
but I
FC.
mean, they just changed the name of it.
Yeah, and then no, then it's not FE because I mean, site local, the prefix used to be FEC, FED, FEE, and FEF.
Oh,
Yeah, but now
okay.
it's FC0, FC00
Yeah.
is what to be looking for. So yeah, that's all the information. Yeah. And then what other type of addresses before we finish for today? Um,
We unspecified. We already
good one.
spoke about that.
Unspecified.
Yeah.
And what is unspecified?
I think unspecified would be something like the ones you have the 0.0.0.0 for DHCP before you have a DHCP
Yeah.
assign an address to you.
Yeah.
Yes. So with that whole DAD detection process that goes on, it's like confusing to me right now, but I believe it's used for that.
Of
Before
zero
you
dot
have an
zero.
IP address.
Yeah,
Yeah.
it is. Yeah, but again, it's not going to be passed between routers. But yeah, so it's used for that purpose. And this is /24. So in this case, it will be in the case of IPv6, it's going just going to be column
Okay.
slash 128. So that's basically
Unspecified.
yeah, because
Unspecified with all zeros. Yeah,
yeah,
all
so
zeros.
basically everything is all zeros. So it could be used in a situation where there's no source address for
Yeah,
a node, and basically they're just using
fine.
that.
Yes, yeah.
Yeah,
Yeah.
yeah, good one. Any other type of addresses?
Loopback. Did we
Which
finish loopback?
which one is that? Oh, loopback. Yeah, good
Oh,
one.
we have the most, the important ones, multicast, one-to-many, and anycast.
Yeah. So loopback
Yeah.
addresses. So what are the ranges for loopback addresses?
Loopback, I think, colon 1,
Yeah, good one.
slash 128,
Colon one. Yeah, okay.
28. Yeah, and
And what other type do we have? So this one is equivalent of the 127.0.0.
yes, anycast.
Yeah.
I believe anycast would be like, so used for, huh? Morris has something to say.
Okay.
It's not equivalent to 00.
So what does Moise say? Let's see. It's not equivalent to 000/24. So explain to us, Moise. Explain to us. So um, let me bring up the textbook I was looking up today, and let me bring up what it has to say about unspecified. So it says an unspecified address is an address of all zeros. It says the source address may be unspecified by devices that have yet to learn their address, which is basically what Sarah said. And it says packets with an unspecified destination will be dropped by routers. So, okay, 0.0.0.0, that is true. That's true, because 0.0.0.0 is not unspecified in IPv4. Is it? Let me say something is going to 0.0.0.0. So for example, if you
No,
have a
no.
default route and you say default route that is anything else goes to this one. So that's not an equivalent of
Oh, that's
unspecified.
different.
Yeah,
Yeah, that is different. That is like
yeah,
anything that doesn't match
yeah,
anything. I mean, you just shoot it off to the
yeah,
whatever your default
yeah.
routers. Yeah,
So thanks for
that's different.
correcting us on that, Moise. Good one. So that is not an equivalent. So this one unspecified is just basically can be used by devices that have not yet learned their addresses, but it is not the same
Mm.
thing as the 00 on IPv4. Okay, yeah. Anything else? Kisera mentioned any casts. So what about that?
Anycast is more than one node. The reason being that the closest server that you have that you want to reach, yeah. So you have, let's say you're traveling and you have whatever towards your right, you have a server that's closer to the one that is to your left. Excuse my analogy over here, but yeah, the closest one is the one that you use. The closest router is the one that I'm messing up.
I'm more
Okay,
confused now.
if I
Help
give
me.
so, all right, I'm gonna try this again.
Kevin, did you understand what Sarah said
No, but Jerry did say something in the
in the chat window?
Jerry
It
said
says any
yes.
cast addresses are designed to provide redundancy and load balancing in situations where multiple hosts or routers provide. So break it down a bit. That's one thing. So Jerry and Sarah help us. You understand this? The rest of us don't. Help us.
I will try once
Yeah.
again. I will
Okay.
try.
No problems. Carry on.
You are assigning the same IP address to more than one interface, more than one router.
Ah. Okay.
So
Yeah.
you have a packet which is sent to an Anycast address.
Yeah.
It is routed to the nearest router interface that you have.
Okay. I see. So
Oh,
something
it's
Alright?
like
similar.
So it's a measure,
HSRP.
Yeah. Something
the
similar to that.
distance, measure of distance. Yeah. So many
Ah.
nodes will share. So whoever is closest to you, you will route to that router.
Yeah, got it. Got it. So, Kevin, is that a bit clear? I think that's a bit clear for me. So basically
Yeah.
something similar to like the way HSRP functions, where you have, two the same IP are assigned to two interfaces. So you send the packet to the Anycast, like in load balancing situations, like Microsoft does that. So you send the packet to the Anycast address, and the Anycast will determine, which interface to send it to.
Yes, I think the reason they came up with this is the mobile devices that we hold and we move around a lot with them,
Yeah.
accessing things everywhere. So
I
that's the
see.
reason.
Okay. Yeah. Makes sense.
Yeah.
Makes absolute sense. Kevin, is that clearer now? I think
Yes,
that's
that's
clearer for
good.
me, yeah. And yeah, yeah, Powell always brings some good point. Powell says, okay, 0.0.0.0. So what about 0.0.0/8 reserved for self-identification? So you're right again, Powell. So that's one of the benefit of having like experts like you in the Hangout. So what Moy said, let's put it back and say equivalent of this one. Not slash there, not 0/0 but the other one, sorry. Equivalent of this one. That is reserved for self-identification. Yeah, before it has learnt its own address. And of course, there's like the multicast range, but we won't start describing all that one today. But I think we've run over our time. We've gone beyond the times for today. But really nice hanging out with you guys today. I hope even for today, even though we've not gone into like a lot of details and stuff like that, I hope that we're much more familiar with IPv6 than we used to. And then actually, if we go back to read our textbooks or watch our videos or whatever again, things will become a bit more clearer because we're a bit more familiar with it now. Is that true? Yeah. What would you say,
Yes.
Alex? Yeah. So did you get anything from this hangout, Alex and Kerry and Mark?
Oh, I
Yeah.
got a lot. I
Yeah.
got a lot.
There is a site, it's called Fred Bovey, IP version 6. I actually have it in the
Yeah.
chat window.
Yeah.
This guy
You could post it,
has,
please. Yeah.
could
yeah,
you
he
post it,
has,
please?
Let me post
okay,
it. So Sarah, the chat window
yes,
to use is the other one, but I'll copy this one. Don't worry. I'll copy it and post it in the
okay,
other chat
fantastic.
window.
Yes. So this guy has a book. It's a very appealing book, and he comes on CLN as well many times. And you should download. It's a free
Yeah.
PDF. But yeah, a lot of figures over there, diagrams. It's very easy to understand IP version 6.
Yeah.
So just get the book.
Yeah.
I see that he has redone the site now.
Yeah. Good one. So what's what's Powell is asking is that on a scale of 1 to 10, who are you now? I'm maybe a 3 now
Can you
with the
put the website on the screen for me?
yeah. So it's there. So if you look in the chat window to the right, you'll see the link
I
there.
can't see the chat window.
Oh,
It's like
okay.
I'm on a
Let me put it on the
tablet.
screen.
It
Yeah.
doesn't.
So can you see that? So that's Fred Bovey IPv6.blogspot.ae. Can you see that?
I can't see your screen. I just see your. I just see you.
Ah, okay. Sorry. Have I stopped sharing screen? Oh, that's true. Sorry.
Yeah.
Sorry about that. Sorry. So let's go back. So can you see the site now?
Yes,
Okay.
that's right.
Fred
Bovy
Bobby
IPv6
IPv6.
dot blogspot dot ae. Yeah, good one. Really, really good one. I'll say with I was probably a 1 before, but with
His book is there somewhere. You'll have to look for the PDF. He's done his site again just very recently, so
ah
you need to look for it. But it's a very good book, yeah.
nice one.
Cool.
Thanks for that.
Well,
Thanks
thank
for
you
that.
so much,
No,
David. That
thanks
was
very
a great
no no
hangout.
thanks
I
very much,
learned a
guys.
lot from it.
No, thanks very much,
Anytime.
everyone. Thanks very much, every
Thank
single one. I mean,
you.
I've learned a lot also myself.
Hopefully, see you next week.
Yeah, we'll see next week, and
Yeah.
then we'll pick up from that next week. See
Maybe
you
I'll
next week,
be.
guys.
Maybe I'll have my CSEN.
Yeah,
Oh, good luck.
Good luck.
if you
If
have
there's
that
an
post,
available,
Don't forget
if
the
there's
show
an
command.
available appointment, I'll take it.
yeah, if you
Don't
have that
forget the
post,
show command.
yeah, if you have that posted
Yeah,
in the chat window, so it can encourage others also. Yeah,
definitely I
sorry, in
will.
the community and stuff like that. Yeah, nice one. Yeah, thanks very much, guys. Have a
Okay.
wonderful, enjoy the rest of the
Okay,
weekend and stuff.
bye-bye.
Yeah, bye bye.
Okay,
Bye.
Well,
bye.
Bye all.
bye.